Hi, this is Michael Kohler with Coral Castle Explained. I'd like to introduce a concept that I discuss in my book, which directly relates to the secret that Edward Leeds Skalnin used to make the Coral Castle. It's a concept called phi. Although many people have heard of this term, used in regard to sororities like Phi Beta Kappa, it is actually a mathematical concept that is at the basis of everything in nature, from flowers to seashells, even to the structure of the human head, and even outward into infinite realms, as seen in the work of fractals. This mathematical concept can be found throughout art, architecture. Virtually everything in the universe that we have today incorporates this mathematical concept. So in this video, I will try to make the concept of phi easy to understand, and to do so, I must begin with the work of Leonardo Fibonacci, the creator of the Fibonacci sequence. Fibonacci created this sequence when trying to figure out a very simple problem. How many pairs of rabbits are created by one pair in 1 year? This almost humorous problem that he set out to solve led him to discover a simple numerical sequence that is at the foundation for an incredible mathematical relationship directly related to the concept phi. Now, understanding the Fibonacci sequence is actually very simple. Here it is in front of you, starting with the number 0 and 1. Each new number in the sequence is simply the sum of the two before it. So 0 and 1 makes 1, 1 and 1 makes 2, 1 and 2 makes 3, 2 and 3 makes 5, and so on, out to infinity. So if you take those numbers and you make squares with those widths, they come together in a rectangular form. The rectangle grows in a spiral format. So when you connect the opposing corners of the blocks with the spirals, it creates an infinite spiral. This is the same spiral-like format that is found throughout nature in plants, seashells, and other things that are naturally grown. In this very clever video called Doodling in Math, Spirals, Fibonacci, and Being a Plant, this person shows the rectangular representation of phi that I just showed you, along with the spiral curve, showing how they're connected, and also begins to show you different things, showing how this pine cone has the phi or Fibonacci sequence built into it, and this happens every single time. Now that you have an understanding of the Fibonacci sequence, let's take a look at another concept called the golden ratio. The golden section or ratio is a ratio or proportion defined by the number pi, phi. It is 1.618 and it goes out to infinity. Essentially the ratio of 1.618 to 1, as you can see in this example with the lines, is what becomes a divine proportion, a perfect ratio that is seen in architecture today. So how does this concept of the golden ratio relate to the Fibonacci sequence? Remember, to find the golden ratio, 1.618, you take the longer segment and divide it by the shorter one. This can be seen in this mathematical formula here. If you were to think of this from the standpoint of the Fibonacci sequence, to do the same thing, you would divide the larger number by the preceding number, which is smaller. And if you do this with the Fibonacci sequence, every time that you do it, you get closer to the perfect number, 1.618, the number otherwise known as phi. In my book, Coral Castle Explained, I show how this symbol here, this representation of phi in the Fibonacci sequence, is actually built into the Coral Castle itself. By laying over this rectangular representation of phi over pictures of the Coral Castle, you can see that it actually lines up even with the spirals interconnecting with different coral pieces throughout the castle. I believe that phi and the Fibonacci sequence, these mathematical concepts, are not only built directly into the Coral Castle, but that it is also directly related to the secret of Edward Leeds Scalnan, the one that he used to build the Coral Castle itself. Until next time.